All right, Jordan. So we're on section 2.2. We're looking at example 3 now, because before you left, we did example 1 and example 2. So this question asks us for which values of the variable is each radical defined. So what I've written up here, you can see in the green, it's variable is a letter. So in our case, our variable is x, and the radical is that weird little check mark symbol. So what we really want to look at is we're going to look at three cases of what our variable x could be. So we want to know what happens when x is negative. Okay, so we're going to pretend x is negative. So what we really want to see is if we take negative x, right, and we try to cube it, we're going to get some sort of negative number. Okay, so I won't even write it like that. It'd be negative. And then again, this is just a plain old square root. So here, because when we cube a negative number, we get a negative number, we cannot actually take the square root of a negative number. So what ends up happening is we want to know if 54, the square root of 54 times some sort of negative number, if that's possible. But we know if we take 54, which is positive, and multiply it by a negative, we're going to get some sort of negative number. Okay, it doesn't really matter what x is as long as it's negative. So again, here, because we're trying to take the square root of a negative number, we can't do that. So this is not possible. So what we know now is that x can't be negative. So our second case is what happens when x is 0? Okay, so if we take 0 and try to cube it, we get 0, so that's okay. And then we get the square root of 54 times 0, which gives us the square root of 0. And the square root of 0, I know that's a weird concept. I think it's just 0, but we can do that. So this is possible. So I say yes. Um, so yes, x can be 0. And then our third case is when x is positive. Whoops, that's not how you spell positive. So when it says, this question asks for which values of the variable is each radical defined, we always check these three cases: when our variable is negative, when our variable is 0, and when our variable is positive. So if we take some sort of positive number, okay, and we try to cube it, we're going to get some sort of positive number. And then the square root of 54 times some positive number. Well, a positive number times a positive number gives us a positive number. And yes, we can take the square root of a positive number, so this is possible. Okay, so x can be positive. So what we figured out is x can't be negative, x can be 0, and x is positive. So how we would answer this question is we would say that, what am I looking at? Oh, okay. I didn't do the check your understanding. This is the example. So what we're saying is x has to be greater than or equal to 0. Okay, and that means x can be 0, x is positive. Kind of curious why I did the example instead of the check your understanding, but that's okay, that's okay. Let's look at, whoops, that's not right. Woo! I don't like doing this, this is the first time I've done this in a while, so I'm a little bit rusty. I haven't even taught this to the class. So let's look at B. So, okay. So we have the cubed root of 12 times x to the 5th. So again, the first thing we want to do can x be negative? Okay, so if I take a negative number and I put it to the power of 5, we know if we take a negative number and put it to an odd power, we're going to get a negative answer. So then what happens is we have the cubed root of 12 times some negative number, and we know 12 times a negative number will give us some sort of negative number. And it is possible to take the cubed root of a negative number. Why? Well, we know if any of our indexes, so the number I just circled, is odd, it's always possible to take that root of, or that radical of a negative number. So this is possible. Yay. Okay, so yes, x can be negative. What about x is 0? So again, if I take 0 to the 5th, I get 0. And then if I try to take the cube root of 12 times 0, well, that's just the cube root of 0, which is just 0. So totally, that's possible. And then I want to see, can x, oops, we already did negative. Can x be positive? So if we take a positive number and we put it to the power of 5, we're going to get a positive number. And then if we take the cubed root of 12 times some positive number, so 12 times a positive number, it's positive. And for sure, we can take the cube root of a positive number. So this is possible as well. Okay, so we put a check mark there. Okay, so what happens here is all three cases are possible. So that means x can be any number that we normally deal with. So x can be any real number, to be more specific. So we're going to say x belongs to the set of real numbers. Okay, so this is saying x can, so what this means is x can be any number we want. Okay, so how this reads is this is x belongs to the real numbers. So this symbol here, this is an epsilon. It means it belongs to, and then this super R is real numbers, and we kind of went over that. So I know I didn't go over that with you before, that new epsilon, that belongs to symbol. I hope you're okay with that. Okay, so let's look at the fourth example. So I think this time, instead of, I had it all set up to do the examples. Let's do the check your understandings instead, because you can look at the examples yourself. So this is the check your understanding on page 99. So what this question asks for is we want to simplify, or says for which values of the variable is each radical defined, and then simplify the radical if possible. So we're going to do those same 3 steps we did for the last question, and then we're going to simplify the radical. So that's what we did in example 2. And I'm just about out of time, so we will do this in the next video.